Question 7, the straight line y equals to x plus 5 meets the curve this at single point, right, at single point. Find the value of the constant k. So, for this value we have this the curve 2x squared equals to 2x squared plus 3y squared equals to k, right, and we have the value of y equals to x plus 5. So, we can substitute that value over here. So, this will become then 2x squared plus 3 and y square is x plus 5 squared equals to k, right. So, then we can expand it 2x squared plus 3 into we have x squared plus 2ab, that is 5 times 2 10x plus 25 equals to k. Okay. So, now then we have this 2x squared plus 3x squared plus 30x plus 75 equals to k. Now, just rearrange them. 3 plus 2 it is 5x squared plus 30x plus 75 minus k. So, this is going to be the constant value. So, now as we are given, let us say this is equation number 1, as they are given that they meet at a single point. So, if they meet at a single point, so that means discriminant of this going to be 0. A here is 5 and B is 30 and C we have 75 minus k, right. So, because they meet at single point, they meet at single point. So, that means discriminant should be 0. What is discriminant? You know the formula. Discriminant is b squared minus 4ac is 0. So, b here is 30 squared minus 4 times 5 times c is 75 minus k equals to 0. So, this is 900 minus 20, 75 minus k equals to 0. So, 900 minus 20 times 150, 1500 minus 20 k equals to 0. So, minus 20 k and then when you subtract this is 600. Yeah, equals to 0. So, 2 k is 600, sorry it is not 2 k, it is 20 k. So, k is 600 over 20 which is 30. So, value of k is 30, that is our final answer, right. Now, find the coordinates of P. So, for the coordinates of P we have the this value of k. So, we are going to substitute from equation 1. From equation 1, what do we have? We have here 5x squared plus 30x, 5x squared plus 30x plus 75 minus k, k is 30 now equals to 0. So, 5x squared plus 30x plus 45 equals to 0, right. So, x squared, we divide the whole equation by 5. So, this is going to be 5x squared plus 6x plus 9. So, it simplifies, actually the values will be easier. Now, we can factorize this. So, as I can see, this is x plus 3 whole square equals to 0. So, from here we will have x will be negative 3 and negative 3, the repeated value, that is what was the question. So, now what do we have? We have the equation y equals to x plus 5, right. We have the value of x, so we can find out value of y which is 2, right. So, point P has the coordinate negative 3 and 2. So, this is our answer. Okay. Hope you guys are getting all the answers and you understand everything. Kindly subscribe to the channel if you are new to the channel, and I will wait for your feedback on these questions, how you want me to do, and if you have any questions just write in the comment section. So question A, 8a, an arithmetic progression. This is arithmetic progression such that the first term is 6 and its 10th term is 19.5. So T1 first term is 6 and T10 is given to us as 19.5. Find the sum of the first 100 terms of the arithmetic progression. So to find out the sum of the 100 term, you know the formula. So we have the formula here, Sn, sum of n terms is n over 2, 2a plus n minus 1 into d. So for this we need to know we have the value of n, as we are looking for 100 values, but we don't have the value of d. We need to know the common difference. So we will find out from here. So formula of Tn, nth term is a plus n minus 1 into d, and this nth term, 10th term we have okay, let me write it down in the next line. So we will write down here T10 is a is 6 plus 10 minus 1 into d, and this is given to us 19.5, right. So this is 6 plus 9d equals to 19.5. So 9d equals to 19.5 minus 6, which is 13.5, d divided by 9. So this is 1.5, right. So d is 1.5. So we got d 1.5. Now we can find out S100. S100 is going to be 100 over 2 into 2a. A is 6 plus n minus 1, that is 100 minus 1 into 1.5. So this is 50. This is 12 plus 99.1.5 times 1.5, sorry, this is 50 into 12 plus 148.5. just use the calculator. So once you calculate this, you are going to get S100 as 8025. So this is our final answer, right. Now part B, geometric progression A1, A2, A3 is such that A1 is 24. Now we are given A1. Now this is a geometric progression. Now this is not arithmetic. So A1 is 24 and the common ratio is half. The sum to infinity is denoted by S. The sum to infinity of the even number terms, right. So A2, A4, A6 is denoted by SE. Find the value of S and SE. So we are looking for the sum to infinity of the term and the sum of the even numbers. So for that, so first of all, we know that sum to infinity, the formula is A over 1 minus R. So sum to infinity is denoted by S, as he said, denoted by S. So S is equal to 24 over 1 minus 1 over 2, which is 24 over half, right. So this is 24 times 2 over 1. So S is 48, right. So one thing is done. Now we are looking for SE, which is number of even terms, I mean the sum of even terms. So for this, the even terms, we will be looking for the terms. So first term is 24, right. Second term, as the common ratio is half, so we are multiplying by 2, meaning dividing by 2. So that next term is going to be 12, 6, 3, 3 over 2 and so on, right this. So even number terms are even numbered. Even number terms are going to be like this, 24. This is A1. Sorry, not this one. We will have the even terms are going to be this 12, 3 and then next one, right. So this next is going to be 3 over 4 here. So I am writing even number terms here, 12, 3 and 3 by 4 and so on, right. So now we are going to find out the common ratio. So, the common ratio for this one is going to be this second term divided by the first one, that is going to be 1 over 4, right. So, now SE, that is sum of even number of terms, A over 1 minus E. So, also 1 minus R. So, also because even number of terms there is no limit, so that is also considered as infinity. So, we do not know how many terms are there. So, A minus R. So, this is A is 12 now, 1 minus 1 over 4, right. So, this is going to be 12 over 4 minus 1, 3 over 4. So, we can write it down as 12 times 4 over 3, 4 times 4 it is 16. So, S of even numbers is 16. So, this is our final answer, right.